In exercise 4, now we are looking at three-dimensional vector fields. So again, we are trying to match. In this case, we want to match formulas for vector fields to the plots. And I'm not going to do all of them. I'm just going to do one or two. So let's look at C right here, because that has that vector r, but this time in 3D. So this is xi plus yj plus zk. What is that going to look like? Well, in 2D we saw that this vector gets larger the further away you move from the origin, and it always points straight out from the origin. So in 3D it behaves just in the same way, just in 3D. So which of those vector fields that are shown behaves like this? Well, it's the first one. So this one right here, this is going to be the vector field for C. You can see that the vectors, they're kind of like getting shot out of the origin, and they point straight away, and they get longer the further out you go. So that is how that vector field f of r equal r, what that behaves, or the way that behaves. Another one that I want to look at is E, I plus 2j plus k. And what's special about that? Well, that is a constant vector field. No matter where you are, the function value is always I plus 2j plus k. It's always the same vector no matter where you are. And sometimes that is not so easy to see in 3 space. In 2 space, it's pretty easy to see, and you hopefully saw that. Well, no, you haven't seen examples of that, but you will see that in going forward. Here in 3D, sometimes the perspective gets in the way of showing exactly what that looks like. It's actually this one here in the upper right. And when you compare these vectors, it looks like they're getting longer, but really they are not. It's a perspective that makes us think that. What we can see is that they are pretty much all pointing